Hello class. Today we are doing 5GO 3.4. Okay? We are to round decimals. Now, when we round decimals, we look at the neighbor to the right of the decimal place we are rounding, and we determine that that neighbor will determine if the place that we're rounding stays the same or goes up to the next numerical value. If it stays the same, if the number next door is 0, 1, 2, 3, or 4. It goes up if the number next door is 5, 6, 7, 8, or 9. Okay? So first of all, let's determine the place that we are rounding. Here, we are rounding the 4, and that 4 is in the ones place. Okay? So we say ones. The number next door to the ones place is the 7. It is actually to the right of it. The 7 tells the 4 to go up 1. So the 4 goes up to a 5. We put the decimal point here, and the 7 and all the numbers that follow it disappear and become 0. Okay? That's how that's done. So let's look at number 4. On number 4, we must identify the place first. So we do that by putting a 1 under the ones place and zeros that follow. And that lets us know that this digit falls in the hundredths place because this is 100. So that's the hundredths. It's after the decimal point. Okay, it is the hundredths place. The number next to it is a 6. That 6 tells the number that's in the hundredths place based on its value to go up to the next numerical value. So the 0 goes up. That's what 6 tells it to do it. Okay, so we keep the numbers in front, and the 0 goes up to 1, and the digits that follow are 0. Okay, let's look at 6. Number 6, the place value here, put a 1 here, 0, 0. That place value is in the hundredths place. There we are. And then this 5 tells us that this hundredths place goes up to the next numerical value. So instead of being 6, it goes up to 7. So we keep the numbers that are in front, decimal, keep. This goes up to a 7, and the numbers that follow are 0. Let's look now here. Name the place value to which each number was rounded. So here, if we take this number and put it under here, we know that these two numbers disappeared. So obviously the place that was being rounded is here, the tenths place. Let's look at number 10. Number 10, we make the determination that if we put this here underneath, we know that this disappeared. But look what happened. This 7 could have told the 9 to move up 1, and if so, that would have caused this to also move up, or the 9 could have told the 1 to move up, and that would have, we would have determined to have, we would have, it would have resulted in an answer of 2.0. So either way, it could have been the tenths place or the ones place. So both of those would be valid answers. Okay, let's look here. If we do this, and we know that these disappeared, then obviously this was how the 6 indicated to the 4 to go up 1. So it was rounded to the ones place. The ones place made the change. Okay, let's look here. Number 14, it says round 7 and 954 thousandths to the name, to the place name, so the hundreds. So the hundreds place is here. The 4 tells the 5 to stay the same. So we keep the 7, the 9, and 5 stays the same. Okay? There's no change. All right, here, number 16 to the 10th place is here. This is the 10th. The 9 is next door, tells the 1 that's in the 10th place to go up 1. So here, okay, and everyone behind it is left off. Here, the ones place, this is the ones place. This 1 tells the 8, which is in the ones place, to stay the same. And that's what happens here. Okay, now let's look at number 20. Number 20, Alex batting average is 346 thousandths. What is his batting average rounded to the nearest hundredths? So if this is the ones, the tens, the hundreds, this 6 indicates to the 4 to go up 1. And that will be his batting average. Okay, see you in the morning.